Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know. Right? Right. Second, let me have a quick look. Like, if you are in online, please say hi so that I will understand. You people are in online, and please say okay. Like if the voice is clearly audible to you. Okay. Right. Right, guys. I just want to know. I just want to say today's session is all about summary of IS 456 2000. For beams, I want to discuss today with the help of numerical problems. Okay, that is our intention for today. And about the clauses of IS 456 for beams and slabs, I completed. So numerical problems I want to discuss for today's session. Right. So hi everybody, hope you are fine and your people are doing well. And welcome to India's largest online e-learning platform, Unacademy. Right. So before I start the session, I just want to convey one thing. Like so much of free content is already happening in this Unacademy learning app. If you are a serious aspirant of GATE or ESE or any other competitive examination, then I can definitely recommend you to install this Unacademy learning app. Because free content is there. One thing. And if you want to follow me in an Academy Learning app, use this link. When you use this link after you install the Unacademy Learning app, you will be redirected to my page. And if you are able to follow me directly, three advantages will come to you. Already the free content that was made by me in an Academy Learning app, you are able to access when you are able to follow me. Second advantage, at the end of each and every session, we will provide a PDF notes for free classes also. You are also getting that for free of cost. And the future notifications of free lectures of mine will be notified to you. So all these three are advantages when you are able to follow me, right? So say hi if you are in online, right? Yeah. I just want to convey one more thing. Like some people will also ask us, sir, is there any paid course is there in an academy learning app for GATE or ESE or any other competitive examinations? Yes, there are paid courses are also there in an academy learning app. Select the goal, whatever you want to crack as GATE and ESE. And after you select the goal as GATE and ESE in the main tab, okay, in the main tab, go to plus courses. After you go to plus courses in the main tab, you are able to see another tab called get subscription. When you press on get subscription, you will be redirected to the payment page. Whether there in get subscription, if you press, there are two types of paid courses will come into picture. One is plus course and second one is iconic course. Either for plus course or for iconic course, for any course, if you want to get 10% discount, brother, you are bound to use this code VT10. When you use this code VT10, it shows your trust on me, it shows your faith on me, and it will directly connect between you and me, right? So okay, some people will just are okay, I hope there are two, you understand, like two courses, two paid courses are there. Some people will say like, sir, okay, you will show that with the help of screenshot, that is fine. First of all, please introduce yourself. Okay, let me introduce first of all myself, then I will show the screenshots how those courses will be, right? I am Venkata Tilak, completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also. My background of education is completely into structural engineering. So here also in an academy, I'm going to teach only the structural subjects, structural engineering subjects. Some people will say, sir, is there any specialty for this university from where you people had graduated? Yes, brother. I mean, this university ranking is far better than IITs and IIC Bangalore. It was not told by me, brother. It was advocated by almost all the ranking agencies throughout the globe. And moreover, this university has produced six Nobel Prize winners. I hope you can understand. Producing six Nobel Prize winners from a university is not a joke. So you can understand the depth of research potentiality involved in that university. And other than teaching experience, previously I worked as research scientist or research engineer in University of South Carolina for a research funded project. This is in USA. For that same research funded project, I worked as a team leader also. In addition to this one, previously I worked as head of the Department of Civil Engineering in an engineering college. This is in Andhra Pradesh, India. That means I have both local experience within India and global experience outside of India also. Coming to my teaching experience, totally I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. Being a structural engineer, I'm a structural design consultant. Being a structural engineer, even till today, I'm also working as an independent structural design consultant. I personally give structural drawings to my clients and material testing reports to my clients. This is my brief background, brother. Okay, some people will say, sir, can you show us how we can take the paid course? After you install this Unacademy learning app from the Play Store, go to Play Store and type this name Unacademy learning app, and you install that. After you install that one, this is the main tab. In the main tab, go to Plus Courses. After you go to Plus Courses in the main tab, there is another tab called Get Subscription. When you press on this Get Subscription, right, you guys will be redirected to two different courses. One is like this, either Plus course, or second one is Iconic course. So I will show you what is the difference between Plus course and both are paid courses only. In Plus course, if you want to take 10 percentage discount, or even in Iconic course if you want to take 10 percentage discount, here I hope you are able to see the referral code. In the referral code, you must and should use this code VT10. When you are able to use this code VT10, directly 10% discount you are bound to get on any course, right? So some people will say, sir, what is the cost for 12 months subscription of this GATE and ESE? For 12 months, the cost is 27,225 for GATE and ESE. And more than 6 months course, there is a free cost EMI is also available. So you can have a look directly. If you want to pay by installments, you can pay by installments also. It's not at all a problem. Some people will say like, sir, what about the Iconic course? If you select this Iconic, then in such case the cost for 12 months course after 10 percentage discount, if you use this code VT10 directly, you will get for 45,225. Right. For any of the courses to get 10% discount, you must and should use this code VT10. Okay, some people will say, sir, what I will get if I had taken the paid course? Maybe like Plus course or Iconic course. If I get the paid course, what I will get? The first and foremost advantage is instant doubt resolution is possible when you had taken the paid course, brother. So through daily live classes, you can directly chat with the educator, and the educator will resolve all your doubts instantaneously. That is the first and foremost advantage. Second advantage, I can say, like test series support is also there. We at an academy, we are providing test series support so that you can understand at what level you people are in terms of performance when compared to the topmost students of an academy after writing the examination. We are providing those test series in the form of live tests, quizzes, mock tests, daily based tests, grand tests, and if you write all these tests, definitely we are pretty much sure like you are able to get very good rank. Definitely you will get some definitely pretty good exposure. And about the third advantage is there is no need to plan yourself. We will provide the entire each and every plan. If you follow that plan, definitely we are pretty much sure like you are able to crack any sort of competitive examination. And we plan the syllabus, and we plan the number of hours, and even this test series also in such a way that so that after you complete all that stuff, definitely you are able to get pretty good rank. I just want to convey all the courses provided by an academy are completely structured courses, right? And finally, the final advantage here, final advantage if you have taken the paid courses, on some of the cases you may not come down to live. In such cases, in every case we will provide the same lecture in the form of recorded version. For n number of times you can watch the same recorded version through the comfort of your device, like maybe mobile phone, or maybe a PC, or maybe a tab. So depending on your comfort, you can access the same recorded lecture through comfort of your device. These are some of the topmost indicators that we have directly in an academy learning app. You can have a quick look at them, right? And I just want to convey the course will be taught separately in English and separately in Hindi. So some people had a doubt like, so is it a course is a bilingual? So the course is not bilingual. If it is English, it will be taught completely in English. If it is courses are also in Hindi, so it will be taught completely in Hindi also. So there won't be any language barrier also, brother. So that you are comfortably, you are able to understand the things. So the batches will be separately for English, whereas batches for Hindi will also be separately. Some people will also ask us, sir, okay, in GATE and ESE, till now, how many courses you people had launched? Till now, we people had launched 8 courses. Out of these 8 courses, few courses are long-term courses, few courses are short-term courses. Two courses are in English, two courses are in Hindi. When you had taken subscription, maybe for one year or whatever that may be, within that 1 year span, you will be provided access to all the courses that are launched in your particular stream. Definitely that are going to be launched in your particular stream. Definitely for that 1 year duration, right? So there won't be any language barrier for you also. Yes. I just want to convey one thing. Every day, my classes are happening in this Let's Crack Gate and ESC Civil YouTube channel. My classes are happening every day by 11 p.m. So you can come down to my classes. This is free content. You can say the same thing to your friends so that they will also get benefited. And last but not least, I just want to convey before I start the session. Please subscribe to our channel so that you will not miss even a single free content from this channel, right? And you can say the same thing to your friends so that they will also get benefited. So please subscribe to this Let's Crack Gate and ESC and don't forget to press the bell icon. If you press the bell icon, the future coming videos will be notified to you, right? And you please please raise a thumbs up so that we can do more free content for you. And I already started a Telegram group for you guys. This is the name of the Telegram channel and this is the name of the Telegram channel. Also, if you want to come down to this Telegram channels, also you can use this link which is given below. Definitely, if you press this link, definitely you guys will be redirected to my page. Right. So shall we start the session? Right. So coming to the session, today's session, a singly reinforced, I hope you are able to see, a singly reinforced rectangular section of 200 millimeter wide, okay, 200 millimeter width is there, and 400 millimeter effective depth. Okay, there is a, they are saying some 400-meter effective depth, maybe some steel, I don't know. So 400 millimeter effective depth, which we call it as D, which is 400 millimeter. This is P. Okay, is reinforced with 4 bars of. Okay, they are saying 4 bars. Let me take 4 bars. Okay, the concrete used is FCK is equal to M15, which is 15 megapascal, 15 Newton per millimeter square. What the question is? The question is about ultimate moment of resistance. So they are expecting you guys to work out ultimate moment of resistance, which is called as EM. That means they are expecting you to work out moment of resistance. Ultimate means they are expecting you to work out moment of resistance by using limit state method. So moment of resistance by using state method. Right. So I hope the theory is already known to you. Shall we work out this problem, brother? So to work out moment of resistance, I hope you know. If you work out by step. Step number one is find out XU max. Step two, you need to find out XU, which is actual depth of neutral axis. Step three, judge the type of section. Judge the type of section, whether it is balanced section, under reinforced, over reinforced, whatever that may be, judge the type of section. And coming to step number four, apply the corresponding formula for moment of resistance. Like if it is under reinforced, for moment of resistance or everything, you can write directly compression force. Okay, this is the basic formula. Use XU for I can say under reinforced, whereas use XU max for I can say for balanced section or over reinforced section, use XU max. balanced or over reinforced, right? Right. I hope this is the procedure. I hope you know if you had already gone through the theory one, right? I already teach this theory in previous classes. Okay, can you work out this problem, brother? So shall I work out this problem, bros? So I'm going to work out this problem, and here the number of bars are 20 millimeter dia mild steel bars. You hope you can see these are 20 millimeter dia. I can say mild steel bars. Right. So shall I work out this answer here? So they are saying the width of the section is 200 millimeter. Effective depth is 400 millimeter. Right. And they are saying it is mild steel of four number of rods, 20 diameter. Okay, they are saying. And the grade of concrete is M15. So step number one. What is that step number one? You need to work out XU max or limiting depth of neutral axis. What is the limiting depth of neutral axis for mild steel of grade mild steel of Fe250? XU max is 0.53 times of D. So this we had already derived. If you see the previous classes, the same channel, I had already derived this one from strain triangles. Strain triangle of limit state of flex. Limit state of flex is 0.53 times of 0.53 times of effective depth is 400 millimeter. So if you work out this one, you are going to get it as 212 millimeter. Step number one is over. What is step number two, brother? Coming to step number two, I need to find out actual depth of neutral axis, right? You can write here like find actual depth of, how you can work out the actual depth of neutral axis by equating compression force is equal to tension force. What is the compression force for IS 456 stress block after applying shape and size factor and metal partial safety factor? It is 0.36 FCK B into XU for single reinforced. So, and there is no compression steel. So I am not writing any compression force because of compression. And coming to tension force, what is that answer, brother? It is 0.87 F. It is design stress in tension steel multiplied by area of steel, right? So shall I just substitute this one here? FCK is in megapascal, I can say, because it is right. Let me just substitute. FCK is 15 megapascal. Width is 200 millimeter into XU. XU is the thing I need to work out. This is unknown, right? Which is 0.87 times of Fi, yield strength of steel. What is yield strength of steel, brother? The yield strength of this mild steel is, it is mild steel now, so it is 250 grade. So I can say into area of steel, four rods of 20 millimeter dia. So I can directly write as 4 into pi by 4 into 20 square. Here in this equation, the one and only unknown is x. If you work out this xu, definitely you will get this answer as 253.073 millimeter. This is xu. This is xu max. So I hope from your lectures I already mentioned when we had already shown with the help of derivation also, when xu is when xu, let us suppose if xu is greater than xu max, in such case it is nothing but it is a over reinforced section. Over reinforced section. Designing a beam as over reinforced section is prohibited, but here the section was designed as over reinforced. In such case, the moment of resistance is taken as moment of in such case load carrying capacity of this over reinforced section is equated to that of balanced section. Definitely, right? The same thing here. You can write here like load carrying capacity, or moment of resistance of over reinforced section should be reduced to that of a balanced section. In such case, how we can work out the limiting moment of resistance, because moment of resistance here it is equal to mu. What is the limiting moment of resistance for a balanced section? By using this Fe 250 grade, because here it is saying it is Fe mild steel means Fe 250 grade. For Fe 250 grade we had already derived this mu limit, and that mu limit is 0.148 FCK VD square. This was already derived. Let me just substitute the same thing, or you will get the same answer by from compression force into Legram by taking XU as XU max. You will get the one and same answer. So if I just work out this one, my moment of resistance 0.148, FCK is 15 into B is 200 into effective depth, it is 400 square. If you do this one, this moment of resistance will be definitely in kilo, it will be in Newton millimeter. You will get as 71.2 into 10 to the power of 6 Newton millimeter. And if you want to work out this answer in kilonewton meter, now brother, is 71.2 kilonewton meter. Is the final answer. So if you want to see the options, 71.2, what is the nearest option that is matching here in uh, this objective question? So option B is matching 71.2. I can almost take it as 70. The nearest answer is 72, which is B for Boston. I can pick, right? Right, brother. So can I move to the next question, brothers? Brothers, can I move to the next question? Right, moving to the next question. So moving to the next question. A singly reinforced rectangular section. I hope you are able to see a singly reinforced rectangular section. We take a single rectangular section of 200 millimeter wide. This width is 200 millimeter, 100 millimeter. Same, and the effective depth is 400 millimeter. So they are saying here instead of four bars of 20 millimeter diameter, if the reinforcement is three bars of 20 millimeter diameter, what is the ultimate moment of resistance? They are expecting ultimate moment of resistance when three bars of 20 millimeter diameter is. It's a linked statement question, the same above question, but here in the above question there are four bars are there, but whereas in this question there are three bars are there of 20 millimeter diameter. The number of 20 millimeter diameter, and it is mild steel, right? The question was given in this, and you can work out XU max. What is that answer for XU max? XU max is 0.53 times of D, which is effective depth is how much, bros? The effective depth is 400 millimeter. Effective is 100 millimeter. I can pick. So after this, I can take it as 0.53 times of effective depth is 100. If I do this, definitely it is 212 millimeter. And this is step number one, I can say. What about step number two? Coming to step number two, by writing compression force is equal to tension force, I am able to work out XU, the actual depth of neutral axis. So compression force, how you get it is 0.36 FCK D into XU 0.87 Fy is 0.36 into FCK. What is that grade of concrete? The grade of concrete is M15. No? So 15 into width. The width is 200 millimeter. So XU, which is equal to 0.87 Fy. The yield strength of the steel. Yield strength of this steel is 250 megapascal. Coming to area of steel. The area of steel is 3 bars of 5 by 4 into 20 square. So if you work out directly, the actual depth of neutral axis will be, so coming to the actual depth of neutral axis XU, actual depth of neutral axis XU, it is 189.8 mm. You are able to compare this XU and XU max. How you can compare this XU and XU max? When you compare these two, XU is less than XU max. So what is the type of this section is? The type of section is, I can say it is an under reinforced section, right? Coming to the judging the type of section, judging the type of section classification, it will come under reinforced URS. Okay, when it is under reinforced section, everybody will ask us, "Sir, how to work out the moment of resistance?" Common. If I want to work out the moment of resistance here, Fmu is equal to the ultimate moment of resistance. If I say it is generally, I can write compression force into lever up. Compression force, it is 0.36 FCK B into XU is compression lever up. It is for IS456 stress block for singly reinforced section. It is D minus 0.42 XU. This is the lever. I had substituted the same thing, and I just want to convey you guys. This I had this formulas. Every formula I had already derived in the same channel. If you type like limit state of lecture, I had taken 10 hours and had completed these derivations also. You can have a quick look from the same channel. Okay, but every time for every lecture, it is difficult for me to keep on working out all the derivations. So I had done once. So you can go through the same thing for the rest of the times also. Right? It is 0.36 and it is FCK. FCK is 15 grade, M15 grade. Na? So B is 200 millimeter into XU. The depth of neutral axis is 189.8 into effective depth is 400 minus 0.42 into XU. XU is 189.8. So if you work out this one, answer is 65.6 into 10 to the power of 6 Newton millimeter. And your answer here, what is the thing generally for any type of sections, you need to write compression force into lever. But for under reinforced, you need to consider as XU only. XU is taken as XU. Whereas XU is taken as XU max in case of over reinforced section and balanced section in the same formula. So it is 65.6 Newton, we can say, right? So coming to these options directly, I can say 65.6 now. So I can say like 66. D option will be the correct option for this question when three bars of 20 millimeter diameter are provided, right, brothers? So can I move to the next question, brothers? Right? Please like our video, share our videos, subscribe to our videos, brother. Right? So can I move to the next question? Yeah. I hope you are able to see this next question. A reinforced concrete beam of size 250 millimeter wide. Okay, a reinforced concrete beam is there. Like okay, the width of the section is 250 millimeter. Okay, fine. And overall depth of the section is how much, brother? There is overall depth of 400 millimeter. This capital D is 400 millimeter. And small b, the width is 250 millimeter. Okay, fine. Is simply supported over a span of 4.5 meter. So let me take, I want to show a simply supported beam of span 4.5 meter. I had taken a simple support, and the span maybe I can take as to span 4.5 meter. I can is subjected to 2 point loads P of equal magnitude placed at middle third point. So at middle third point, at middle third, at one third distances, 2 point loads of magnitude P and P are applied in this. Okay. Beam is reinforced with two HYST bars. Okay, this beam is actually reinforced with two HYST bars of Fe 4 and 5, whatever that means. Okay, okay, with an effect to cover. Okay, on bottom base and nominal shear reinforcement. Okay, this is fine. Okay, and here the characteristic compressive strength and bending tensile strength of concrete. So they are saying like FCK is 20 megapascal and bending tensile strength. So the strength of the concrete in flexural tension, the bending tensile strength of concrete is 2 megapascal. They are saying. So maybe I can call it as F is equal to bending tensile strength of concrete, which is equal to megapascal. So ignoring the presence of tension reinforcement, they are clearly given a hint like ignore there is no tension reinforcement. That means there is don't take any sort of tension reinforcement of these two HYSD bars. You can take like no reinforcement. You can assume like there is no reinforcement. Okay, I assumed like no reinforcement. When there is no reinforcement, then it is a homogeneous material. I mean, it is a single material which is concrete only. It is not a composite section. It is a single material like concrete only. Okay, it is a single material, homogeneous material. Okay, find the value of the load P in kilonewton when the first flexural crack will develop. So I can say when the first flexural crack will develop, but that time, by that time this load is nothing but P, right? So that means uh, here I need to use, there is no reinforcement means definitely I can use like simple bending theory. There is no need to use this Euler-Bernoulli's theorem, because Euler-Bernoulli's theorem is applicable to composite sections, because here this type of material is completely a single homogeneous material. So directly I am free to apply simple bending theory. So let me write here, can apply simple bending theory or bending theorem as own as this presence of tension reinforcement is neglected, as reinforcement is neglected, as reinforcement is neglected. Okay, right. I hope you know the simple bending theory. And how you can work out this simple bending theory, this load at which first crack will happen. So I can work out this first crack will happen at the points of maximum bending. So if I draw, can I use the next slide to draw the bending moment diagram and how I can apply this simple bending theory and that equation? Shall I just want to discuss in the next coming slide, right? I mean next slide. Okay. So let me take the help of next slide, brothers. Is that okay? Is that okay? Can I use the next slide, brothers? Okay. This is how the beam is taken, and there are 2 point loads were taken, brother. Point is P, and this is also in this way, and the distance between these two reactions are 4.5 meter. When this distance between 2 points loads are 4.5 meter, I want to show with the help of a bending. This is how I can say, right? And I just want to say this distance is A. Right. So what is the magnitude of this maximum bending moment value is P into A. And coming to A, it is 4.5 by 3 meter in our sense, because these point loads are acting at middle third. So at one third positions of the length, these point loads are acting from each side. So if you know the simple bending theory, M by I is equal to F by Y. This first flexural crack will happen at the points of maximum bending. At the points of maximum bending moment, m is equal to m max. When m is equal to to get a maximum moment of resistance, I need to keep y as y max. So if I keep this as y of y max, and f is the at the maximum moment of resistance, f is the tensile strength, f is the bending strength of the concrete in tension zone. What is the bending strength of concrete in tension zone? It is 2. So if I write this one, m I can write as P into A by I. I can write as, I hope if you see, it is 250 millimeter. This is effect overall depth is 400 millimeter. So I value for this one is I can directly write VD cube by 12. So I by Y max I can write this M max is equal to F into I by Y max. I can write as Z. F is 2 into 2. I can write as 2 Newton per millimeter. To section modulus of the section, I can directly write as BD square by 6. This is from the basic concepts of strength of materials. So which is BD square by 6. B is 250. A is 400 square. BD square by 6. The answer for rectangular section of section modulus. Okay, so this is P into A. Okay, right. P into A. A is 4.5 by 3 na, so I can write 1.5 meter. If I write this as 1.5 meter, 1.5 meter, this is Newton per millimeter. Is in millimeter cube. So meter should also be converted into millimeters. So I can write 1.5 into 1000 millimeters. So if I work out this value of P, I am going to get the answer of this P is 8.8 into 10 cube Newton. But the answer was given, if you see the options, the answer was given in definitely, this is, they are expecting this answer in kilonewton. It was clearly mentioned. So if I convert this answer in kilonewton, it is 8.8 kilonewton. So it's a numerical type of question. You need to type this answer as 8.8, right? It's a numerical type of question. That okay? So when there is reinforcement is present, then you need to use the formulas or the concepts that was given in IS 456. In such case, when reinforcement is present, that type of section is a composite section, composite material, where Euler-Bernoulli's theorem is used. Because the neutral axis will not be exactly at the mid level because of the reinforcement, because of two different type of materials. The neutral axis may be above the mid level or above the below the mid level, right? But here it is a single sized material. As I am neglecting the reinforcement, I am free to use this simple bending theory. Simple bending theory directly cannot be used for I can say composite material. This is a single size, a single type of material. Only concrete is there. There is no reinforcement. Shall I move to the next question, brother? Right. Moving to the next question. I hope you are able to see this next question. Na? Seems like the same question, just like that of previous question. Please go through that question. A reinforced concrete beam of size, okay, of size 250 millimeter. The reinforced concrete beam is there of size 250 millimeter and 300 millimeter overall depth. Okay, and 400 millimeter deep. Okay, and they are saying 100 millimeter overall depth is for overall depth, not I can say the effective depth. It is subjected to point. The same question. Okay, okay. Uh, Same previous question. The two loads are gradually increased simultaneously. Okay, those applied loads are not sudden loads. The applied loads are two applied point loads are gradually applied point. Okay. Uh, okay. The characteristic compressive strength and the bending tensile strength of concrete. They are giving FCK is 20, whereas the bending tensile strength FB or F whatever that means, bending tensile strength of megapascal. Actually, we are neglecting this, okay, but they are instead of 0, they are giving this bending tensile strength of concrete is 2 megapascal. Okay. Question is here the theoretical failure strength of beam for attaining limit state of collapse. So by the time while this loads has reached to limit state of collapse, so they had kept two what you can say two HYSD bars of two HYSD bars of Fe4 and 5 grade. At what loads of application of this P loads, this there is this material or this or I can say this RCC beam is a failure in terms of limit state of collapse. So you can work out the maximum bending moment. The maximum bend equate that maximum bending moment to moment of resistance. Okay. So what is that maximum bending moment? So equate M max to moment of resistance of the section, moment of resistance of RCC beam section. So coming to this maximum bending moment, this is P and if this is A, right? I can directly write as M max, maximum moment of resist, maximum bending moment as P into A, right? So let me use, can I use the next slide to work out this? Can I use the next slide, brother? I just want to use the next slide. Okay. Equate M is equal to maximum bending moment is equal to moment of resistance of the section. I just want to say this we are working out by limit state. Na? I can say ultimate moment of resistance of the section. In such case, M, how I can write this? This M is equal to M max, maximum bending moment, and it is P into A is 1.5 is equal to ultimate moment of resistance. Okay. How I can work out this ultimate moment of resistance? I can write from the stress block of IS 456 2000 because reinforcement is given there. It is not a single material, it is a composite material. Okay, in such case, how I can work out the ultimate moment of resistance? That is the big question, right? So here can I use here moment ultimate moment of resistance MU, the ultimate moment of resistance, compression, right? It lever arm. Compression force. How you can say about this compression? 0.3 into lever arm minus 0.32 FCK. FCK is I can directly write it as CK is I think FCK is 20 megapascal and B the width of the section. What is that width of the section, brother? The width of the section is how much that was given. The width of the section given is 250 millimeter. XU I need to work out. Okay, into D. 1 second, brother. 1 second. I will be back in a minute. Somebody, please excuse me. Sorry, guys. Yeah. So if we say it is D minus 0.42 XU, so I can direct it. If I am able to work out just XU, the problem is over, na? So how we can work out this XU? Shall I need to use XU or XU max? It depends on the type of the section. So here I just want to find out this XU, right? How XU max, if you say, and it is Fe4 on 5, and it is Fe4 on 5 type Fe4 on 5 steel. So XU max is 0.48 times of effective depth. 0.48 times of effective depth is how much? The overall depth is 400 millimeter. Effective depth is overall depth minus effective cover. Effective cover, it is, I hope it is given as 40 millimeter. Effective cover of how much, brother? 40 millimeter. So in such case, effective depth small d is equal to 360 millimeter direct, right? So I can say 400 minus 40, which is millimeter. So 0.48 into 360 millimeter. If I work out this one directly, I'm going to get this answer as 172.8 millimeter. So if I want to work out XU, how I can work out XU? XU can be worked out by equating compression forces. Compression force is 0.36 FCK B into XU, and tension force is 0.87 Fy AST. So try to work out XU from this one. FCK is how much, brother? Uh, the value of FCK, it is 20. B 250. XU is unknown. Okay. Yeah. Is 415 AST. How you can write AST? It is 2 bars, right? 2 bars of 16 millimeter nano, 2 5 by 4 into. If I just substitute, the value of this XU will be 80.00 millimeter. This is XU. This is XU max. To compare both XU and XU max, definitely XU is less than XU max, so it is an under reinforced section. Whereas, so I can use just XU here in this. If it is over reinforced section or balanced section, here instead of XU, I need to use XU max. That is the only. So if I just substitute or provide intentions, value of this P is 31.5. In your previous question, brothers, if you see, when there is no reinforcement is there, the value of this P load, transverse load, when there is no reinforcement is provided, then in such case it is failing fast, like at 8.8. After I keep the reinforcements here in the tension zone, definitely the load carrying capacity of this reinforced concrete beam section has got increased, right? That's what you can understand. So here I can say in this blank, I mean numerical answer type, you need to mention uh, theoretical failure load. Theoretical failure load in kilonewton is 31.56. You need to mention. That is the answer. So can I move to the next question? Shall I move to the next question, brother? Assume straight line instead of a parabola for a stress strain curve of concrete as follows. So this is the stress and this is the strain. So generally, if you see your IS 456 stress block as it is there in IS 456, this is how the stress block you can say. Like maybe if this is stress and this is strain, so maybe I can say this is a parabola from here, and then it's a right line. How you might maybe you might had seen in this way. So this is a parabola and this is a straight line. Here instead of a parabola from this point to this point, actually there is a parabola from here to here. Of this parabola, if these 2 points are merged with the help of a straight line in this way, this then they are expecting assuming straight line instead of parabola for a stress strain curve of concrete as follows, and partial safety factor for concrete material is 1. So here in this case, this value is FCK by, I need to write first shape and size factor of concrete divided by material safety factor of concrete, right? Shape and size factor of concrete is 1.5 divided by, they are saying partial safety factor of concrete, I can write. partial safety factor of material. What is the partial safety factor of material? It is 1. So directly the answer is FCK by 1.5. So if it is 1 FCK by 1.5, it is 0.67 FCK. Hope you are able to see why you got this 0.67 times because the material in the material the partial safety factor is taken as 1. There is no safety factor for material was considered. Only the safety factor for shape and size was only considered. That's the difference. Okay. In this case, I hope when you see this case, right? A rectangle under reinforced. They are saying it's an under reinforced concrete section. When it's an under reinforced concrete section, XU is less than XU max. That is the thing. Okay. Okay, they had given like concrete mix is M20. What is the depth of nodal axis? They are saying what is the actual depth of nodal axis? Brother, I hope you can always work out. Always the actual depth of nodal axis can be worked out from compression force is equal to tension force. Now, how you can work out the compression force? You cannot directly write as 0.36 FCKB into XU because the stress block has got changed. The stress block areas and the permissible values of concrete in compression, these has got changed. The compression force of the compression force value will also get changed. Na? So I just want to tackle that. So let me derive the compression force for this given stress block on my, right, because you are not free directly to use the stress block as per IS 456 direct compression force as given by IS 456 you cannot consider, right? So let me show you here. This is how the stress block, how they had advocated the same way I am taking the stress block. This is the actual depth of nodal line. In the stress block, some part is linear, some part is just like that of a rectangular stress block. So the force in rectangular stress block is taken, force from the rectangular stress block is taken as C1. Force from the linear variation of stress block is C2. If I take in this, and this permissible bending compressive strength of concrete, it is given as 0.67 FCK, not 0.45 FCK as per IS4. Please be aware of that. So, if this is the case, how you can work out this compression force? If this is the complete section, here I can directly take this first area, and this may be second area, right? I just want to convey one more thing, the depth of this uh, constant stress block or rectangle stress block. It is this depth is 3 by 7 times of XU, whereas the depth of this linear variation of the stress block, uh, okay, which is 4 by 7 times of, I can write it as XU. Is that okay? Right? So now you tell me, coming to the total compression force. This I had already derived, brother. How I got this 4 by 7, how I got this 3 by 7 from the strain blocks directly I had worked out. Right. After this one, the total compression force is C1 plus C2. And how I can work out this C1 compression force C1? So I can say average stress from this rectangular stress block, average stress multiplied by this area A1, right? What is the average stress of this rectangle stress block? Here it is 0.67 FCK. Here also it is 0.67 FCK. The average stress in the first area is also 0.67 FCK only because there is no variation in stress. So it's a constant. So the average stress in the first area is 0.67 FCK into area of the first block. What is the area of this first part? This width is B, right? This depth is 3 by 7 times of X. So I can write it is into B into 3 by 7 times of X. I can write in this plus coming to C2. C2 is the compression force that is coming in picture because of this what I can say, because of this uh, linear variation stress block or triangle shaped stress block. I hope you are able to see, right? So what is the average stress in this triangle linear variation stress block? So here it is 0, here it is 0.67 FCK. What is the average value? And the variation is just like that of a straight line. 0 plus 0.67 FCK by, right? That is the common. Let me just write here 0 plus 0.67 FCK by 2. So I can write as 0.67 FCK by 2. This is the average stress acting on second area multiplied by second area. What is the second area value, brother? Second area value is width B into this depth. What is this depth here from here to here? This depth is 4 by 7 times of x. So let B into 4 by 7 times of x. If you work out the compression force as per the new stress block that is given in the problem is 0.478 FCK B into x is the compression, right? So if I equate compression force is equal to tension force, then definitely I am able to work out the actual depth of neutral axis. So if compression force is equal to tension force at the time of limit state, also these equilibrium equations are valid, definitely. If I do this one, generally 0.478 FCK. What is the grade of concrete? M20 is the grade of concrete, brother. And B, the width of the section is B is 250 millimeter, and this depth is the depth of neutral axis. So B is 250 into xu. Xu is unknown. I just want to find out. This is unknown. Okay, which is equal to tension force. For steel, they didn't give any. They didn't mention like you forget the partial safety factor of steel. No such statements were given here. So after considering partial safety factor for steel, the design stress of steel is how much? Fy by partial safety factor of steel. Fy by partial safety factor of reinforcing steel is 1. I can write 1.15, right, into area of tension steel AST. So if you do this one directly, if you work out this one 0.478, I hope you can say what is the yield strength of the steel that was used. The yield strength of steel that was used in this problem is Fe415. And coming to area of steel, what is the area of steel that was given in the problem, brother? I hope you are able to see three bars of three bars of grade Fe4 and 5. So of diameter 20 millimeter diameter. So I can write area of tension steel as 3 into 5 by 4 into 20 square. Directly I can write. Here in this equation, compression force is equal. The one and only unknown is XU. So from this equation, if I work out XU, which is 142.07 millimeter, is the actual depth of the neutral axis after changing the stress block as per the given statements of the problem. So is that okay? So directly, most of the times you cannot directly take the formulas of IS 456. You need to derive your own compression force. You need to derive your own tension force. And based on that one, the depth of neutral axis and moment of resistance formulas will definitely get changed here. Okay, is that okay? So they are expecting here only, if you see the depth of neutral axis from the compression fiber, which is 142.207 millimeter, I can say. Right? Can I move to the next question, brother? Moving to the next question. Right. The next question, the statement is one and same, but the question that was asked is different, brother. So all these questions are linked statement questions. Of course, same above question. Maybe I can say. Maybe I can say. Uh, it's not the same question. I hope you can see this next question, brother. In the design of beams, I hope you are able to see. In the design of beams for limit state of collapse in flexure. Okay, limit state of collapse in flexure as per IS 4562. At the maximum strain in concrete is limited to. What is the actual maximum strain in concrete? This is, if I take, this is the strain block, limit state of flexure. If I take this as strain block, this maximum strain in concrete is taken as 0.0035. This is actually, instead of this, they are asking us to take it as 0.027. Okay, cool. As per the statements, I am changing the maximum strain in compression concrete as 0.027 instead of instead of 0.0035. For this situation, consider a rectangular beam section with the breadth. Okay, let me take a rectangular beam section of breadth. Okay, of breadth 300 millimeter. Okay, let me show the breadth of the beam is 300 millimeter. Effective depth as 450 millimeter. They are saying this. Okay, the effective depth. I don't know how much steel they had provided, but they had given the steel area directly. Maybe 2 bars to 3 bars they didn't mention, but AST is 2000 millimeters. Okay, okay, and they are giving this effective depth. This is the effective depth, 450 millimeter. They had taken in this way. The depth of neutral axis for the section is how much millimeter? That is the depth of neutral axis they are expecting. What is the depth of neutral axis of the section? See here, this is strain block. This is not strain block. Yes, this is strain block, right? So if this is strain block, right? So here it is 0.0027. Uh, Here I just want to make here the stress block also. Coming to the stress block, how I can show the stress block? Let me show stress block here itself, brother. Let me erase this section. Let me erase this section here. Okay, I had erased the section, and this is how the stress block is. Stress block, some rectangular stress block, some part is parabolic. The depth of this parabolic stress block is x1. The depth of this rectangular stress block is x. I just want to say at this point, at this level, the concrete will just start eating. What is the yield strain for concrete? It is 0.002. It is standard value, and that standard value was not asked to change. Let me keep the as usual. Only the change is here instead of 0.0035, here I am taking this value as 0.00. This is 0.0027. The actual depth of x1 and x2 with respect to xu will get changed. When the strain value, this permissible strain value in concrete has got changed, the depth of this rectangular stress block, the depth of this parabolic stress block will get changed definitely. Okay. And coming to the permissible stress value, it is this value is same 0.45 FCK. And how I can take x1 and x2 in terms of xu, right? That is the question. I hope you are able to see this is theta, this is xu, right? What is this value, brother? This value is here x value is x1. So from tan theta, if I write from this strain block, if I write tan theta, similar triangles properties for tan theta, opposite side, I can write as 0.0027 by overall depth is x equal to tan theta opposite side is 0.002 by this depth is just x1. I just used similar triangles properties for this triangle and for this triangle. In this one, I just used similar triangles property. I can write divided by. What is this value of this x1, brother? X1 value is 20 by 27 times of x. So what is x1? X1 is the depth of this parabolic stress block. Depth of this parabolic stress block is high. That's what you should understand. Okay, when x1 is this one, a combination of x1 plus x2 is totally xu. So how I can write xu? X2 is equal to xu minus x1 I can write. from this fundamentals here. The depth of parabolic stress block plus depth of rectangular stress block. This total combination value is equal to total depth of neutral axis, which is XU. What is the value of X2 in terms of XU? 7 by 27 times. Okay, I got X1 and X2. As X1 and X2 values has got changed, definitely compression force values will definitely get changed, right? So I need to work out the own compression force formula here, because here you cannot directly apply 0.36 FCK into XU. That is the answer when this permissible strain is taken as 0.0035, right? But here the permissible strain in compression concrete is 0.0027. So because of which the depth of rectangular stress block will change, the depth of parabolic stress block will change. So because of which the compression force formulae will also get changed. So coming to the compression force formula, if I want to write, how I can write that compression force formula, brother? 1 plus. Can I use the next slide to work out this, brother? Right? Can I use the next slide to work out this, brothers? Right? I just want to use the next slide to work out compression force C1 and compression force C2. Right? So before I do this, I just want to say this compression force C1 is the this compression force C1 is the rectangle. This is the force in this rectangular stress block. Compression force C2 is the compression force in this parabolic stress block. If I consider that in this way, okay. Let me work out directly here itself. Let me. I hope you got a value of x1 and x2 here. Now I just want to rub this x1 and x2 values. I hope you are able to know. X1 is 20 by 27 XU. 7 is 7 by 20. I can write it. Now, how I can write this? Total compression force is C1 plus C2. What is this compression force C1? This is this rectangular stress block. What is the average stress in this rectangular stress block? It is 0.45. I can write 0.45 FCK. The average stress in rectangle multiplied by the area acting on this. What is the area acting on this? B times of x2. So I can directly write B times of x2. What is that B times of x2, brother? So B times of x2 is, I can directly write this x2 as 7 by 27 times of xu. This is compression force C1 plus compression force C2. What is this average value of stress here, brother? From here to here, the variation is a parabola. And the variation is a parabola. What is this average stress here? This is the average stress here. What is that average stress? I can take 2 by 3 times of this is stress plus this is 0 and this is 0.45 of CK. Na? So average stress is 2 by 3 times of 0.45 FCK. So let me write this clearly as, so I can write this one as, what is this average stress? 2 by 3 times of 0.45 average stress multiplied by what is the area acting, what is the area over which this stress block is acting. Stress block is acting over an area of B times of x1 is B. X1 times is 20, x1 is 20 by 27 times of x1, 7 times. If this is how I can work out compression force, compression, force, compression, force, compression, force, total compression. If I work out the total compression, definitely is 0.3388 FCK into B into X. How you will get the total company outputs, right? So shall I use the next slide to work out the actual depth of neutral axis? The depth of neutral axis is always worked out from compression force is equal to tension force. I had derived my own compression force because I cannot directly apply the formula from IS 45 as the permissible strain in concrete has got changed. Compression force formula will also definitely get changed, right? I, now, to work out the actual depth of neutral axis, compression force is equal to tension. The compression force is 0.3388 FCK. FCK is 30 into B. B is 300 into XU. I hope you had seen that B is 30. That value of this B is 300 millimeter. Width of the section is, I can say the width of the section or breadth of the section is 300 millimeter, right? So, and the steel used is 250 megapascal of the, and FCK is 30, B into through 200, 300 into XU is equal to tension force. Tension force is design design tensile stress in reinforcing steel multiplied by area of steel. What is design tensile stress in reinforcing steel? Fi by safety factor for steel. Fi by 1.15. So people call it as 0.87 Fi into AST. Coming to AST, how I can take it as area of tension steel is they had clearly given as 2000 millimeters. Where is the area of tension steel? Let me write here clearly 2000. Coming to yield strength, here, what is that answer of Fy? The answer of this Fy yield strength of steel is 250. Let me write here Fy is, so here the one and only unknown is XU. When I work out this XU here, it is 142.3 millimeters. Millimeter. Here the question is a numerical answer type. So directly here you need to fill in this blank numerical answer type as 142.63 millimeters. Like that, you need to fill this numerical answer type question, right? So can I move to the next question, brother? Is that okay? Can I move to the next question? Yes, moving to the next question. Before I move to the next question, I just want to ask, see, the another question is for the same problem, find the compression. For the same problem, find the compression force. For the same problem, if I want to find out the compression, here I am not free to use 0.36 FCK B into XU. I got in derivation the compression force as 0.3388. Compression force is 0.3388 FCK B XU. This is definitely, it is equal to 0.33 30 B 300 into XU. You got this XU as 142.23 na. So definitely you will end up with the answer 434.88 into 10 cube in terms of force in kilonewton if I write. The question, right? So the answer is 434.88 kilonewton is the compression force for the same problem. See, what when this compression forces tension, when the compression forces formula will get changed. When the permissible strains in concrete has got changed, then the depth of rectangular stress block, parabolic stress block will change. Obviously, compression force will get changed. When there is the partial safety factor of concrete has got changed, then obviously compression force will get changed. In those cases, whenever there is a change in partial safety factors and whenever there is a change in permissible compressive strains of concrete, in such cases I need to derive uh, our own compression force equation, right? So you are, in such cases you are not free to use directly the compression force that is given in IS4. I hope you are able to see the next question, huh? Right. A singly reinforced rectangular concrete beam, singly reinforced. We take a singly reinforced. Okay. A singly reinforced rectangular concrete beam has a width of 150 millimeter and an effective depth of, what is this effective depth of 350 millimeter? Effective depth of 350 millimeter. Characteristic compressive strength of concrete is 20 megapascal. Characteristic strength. Adopt the stress block of concrete given in IS. So use the stress block that was directly given in IS4. It was clearly mentioned, right? Use FE grade. But the question is, okay, B is this FCK. They're expecting limiting value of moment of risk. That is, they are expecting expecting limiting moment of resistance. That is the moment of resistance of a balanced section indirectly. Moment of resistance of balanced section. Balanced section is a section in which the failure of compression concrete and tension steel, both these two are going to fail at the same time. So limiting moment of resistance of balanced section of Fe415 steel. This also I had worked. This I can work out by compression force into lever. If I work out that one and in compression lever arm, if I use XU as XU max, then I definitely I'm going to get as 0.138 CK radius. Direct one. If you don't memorize this one, you need to write this compression force into lever arm. The 0.36 FCK P into XU max you need to. They are expecting the moment of resistance transaction into lever arm D minus 0.4 out tension. Right. When you do this one and in XU max, you just substitute it as 0.48 times of D for Fe4. You substitute directly, you are going to get the final answer as this one. I had already derived. Right. When I do this, how I can write this is 0.18 FCK. But FCK is 20. FCK 20. B is 150. What is effective depth square? I'm just substituting in this answer definitely 0.715 into 10 to the if I want to get this answer in kilonewton meter, the answer is 50.715 kilonewton meter. So this value divided by 10 to the power of 6, if I will get this answer in kilonewton meter. It's the basic way how we can convert from Newton millimeter to kilonewton meter. The answer is 50.7. 50.7. Need to just. Can I move to the next question, brother? Can I move to the next question, brothers? Say yes or no, so that I can work out the next question. Going to the next question. I hope you are able to see the next question. A singly reinforced rectangular concrete beam. Okay, a singly reinforced. A singly reinforced rectangular concrete beam. Okay, has a width of 150 millimeter. The value is 1 and an effective depth of. I hope you are able to this effective depth. RD, effective depth. The characteristic compressive strength of concrete is 20 megapascal. Okay. Characteristic compressive strength of 3 mega. Add up the stress block as given in IS 456 2000. Okay. And use Fe4 by steel. Okay. The limiting area of tension steel. What is limiting area of the tension steel? Uh, Tension steel corresponding to a balanced section is nothing but limiting area of tension steel. Steel area corresponding to a balanced section. So for balanced section, I can write balanced section XU is equal to X. What is that XU max for Fe4 on my steel? Is 0.48 times of effective depth. Now, when I had taken this, XU is equal to XU max. So in such case, how many limiting area of tension steel? They are expecting this is limiting area of tension. How I can work out this limiting area of tension? I can work out this limiting area of tension steel from mu limit is equated to, I hope this is the same problem, which is just the above. I can work out mu limit is a limiting moment of resistance is equal to this tension force into lever. If I write tension into lever, from this one I am able to work out this AST limit. Coming to tension force, it is 0.87 Fy AST, and the area of steel right now for limiting moment of resistance is AST limit. So into lever arm. Lever arm is D minus 0.4 to XU max. Na? Right? XU max is 0.48 times of D. If I work out 0.48 times of D from this one, what is the answer for EMU limit? This question is just like that of your previous question. I hope if you see this previous question, this is just your previous question. Statement is one and same. In your previous question, they expected you the limiting value of moment of resistance, and the value is 50.75. I don't want to work out again limiting moment of resistance. I am taking the help of your previous problem. Same data is there now. I am using that, which is MU limit is 50 point. I can write 50.715 into 10 to the power of 6 Newton millimeter. I can say. And coming to Fy, how I can work out this yield strength of steel, brother? Yield strength of steel is Fe4 on 5. Now I can write Fe. This AST limit is unknown. This is the actual unknown. Okay. And D minus 0.4 to XU max. D is how much, brother? Effective depth is 3.42 times of XU max. XU max is how I can write is 0.48 times of effective depth. 350. How? Now, when I do this, in this one, you should understand like everything is known to me except this AST limit. Except this AST limit, every quantity is known to me. So this is one and only one equation, and from this one and only one equation is 4 on, right? So from this one and only one equation, the one and only unknown AST limit can be worked out, right? So if you work out AST limit from this one, right? Limiting area of tension steel AST limit is 502.6. They are expecting this area of steel in millimeters square. Here in this numerical answer, you need to type it as 502.66. That is sufficient. To type this one, that is sufficient. Can I move to the next question? Right. So yeah, moving to the next problem. I hope you are able to see the next question. A singly reinforced section of 300 millimeter by 450 millimeter. Let me take a singly reinforced section of size 300 millimeter by 450 millimeter effective. Let me and effective depth. Let me is reinforced effective depth is 450 millimeter. The effective depth is from the extreme compression fiber to the centroid of centroid of tension reinforced. And there are three bars are there, two, three, centroid of tension. And three, I can directly write three numbers of 16 millimeter diameter. Maximum strain in concrete. Maximum strain in concrete is limited to maximum strain in concrete is limited to right now. They are saying maximum strain in concrete is limited to 0.003 instead of 0.003. 0.00. That's it. So instead of 0.0035, maximum strain in concrete is limited as 0.003, and partial safety factor of concrete and steel is taken as. Okay. So for that one, I think to show this stress block, I need to rub this. Let me show stress block also here. Okay. This is the thing. What is the partial safety factor for concrete and steel are taken as? Okay. For concrete, this partial safety factor for concrete is taken. I can write FCK by 1.5 is the safety shape and size factor divided by 1.3 is the partial safety factor of concrete. Right, 1.5 into 1. This is the permissible stress in concrete. Coming to permissible stress in steel, it is Fi by 1.5 because the partial safety factor for steel is 1. I can write directly the strain for steel is design strain for steel is design stress of reinforcing steel is Fi by 1. When I do this, definitely you will get some answer. Right. This is how they are saying. What they are saying, what is the critical neutral axis depth? See, the critical neutral axis depth is always worked out from strain block. In strain block, the strain block is not exactly as just like that of the values of IS45. When strain blocks to get critical depth of neutral axis. If this depth of neutral axis is XU max, critical depth of neutral axis XU max. By the time the strain in concrete is, I can directly write this one as definitely is 0.002 plus design stress of steel. What is design stress of steel? Fi by 1.1 divided by Young's modulus of with the strain in tension steel. This is the permissible strain in tension steel, the permissible strain in concrete. Now, when these two are able to possible, by the time the depth of neutral axis is nothing but limiting depth of neutral axis, I can say. So I say this is theta, and obviously this is also theta. And this depth is how much it is minus 0.4. What is that depth that was given, brother? Effective depth of 450 millimeter was given. Maybe I can write here it is. Okay, let me apply The strain, let me apply the similar triangles properties for these strain blocks at the time of limiting failure of section. That means both concrete and concrete in compression in tension zone are going to fail at the same time. So if I do this, I can write here from similar triangles strain block. If I write tan theta, okay, tan theta is opposite side, point not, right? Depth is how much? XU max. Here, if this is theta, then obviously this is theta, this is also theta. Then I can say tan theta is, what is this value? This value is, I can say tan theta is point not 2 plus Fy by 1.1 times of Young's modulus of K divided by the depth is how much? It is T minus zero point 0.42 XU. T minus 0.4 is XU max now. So I should write here T minus zero point 0.4. So in this equation, I hope you know the value of Fy. What is the value of Fy? They are given had given in the problem. F right substitute. Young's modulus of steel substitute 2 into 10 to the power. Right. If you work out directly this one, the XU max by D value, definitely you are going to get as 0.4356. And if you see the effective depth here, it is 450 millimeter. No? To substitute value of effective depth is 450 millimeter, then definitely you are able to work out the XU max, the actual depth of neutral axis. The XU max is how much? 450 into 0.4356. So what is the XU max value? 0.4356 into 450 is 196.04. How you can work out this answer? Depth of neutral axis in millimeter. For a balanced section, I need to work out balanced failure. Depth of neutral axis is XU max. And as this permissible compression strain in concrete has got changed, I can say even XU max by D for this Fe 4 and 5 steel will also get changed. When the strain is 0.0035, the XU max by D for Fe 4 and 5 grade of steel is 0.48. But here I got it as 0.43. Why I had got changed? Why I had got this value? Because the permissible strain in concrete is not 0.0035. It is 0.00, I hope 3. It was clearly mentioned. Because of XU max by T will also get changed. This is how you can understand the concept, right? Can I move to the next question? Right. I think the number of questions were over. Okay, for today, right. I just want to convey, I completed in detail about the limit state of flexure, I mean slabs and beams, and all the numerical problems also I worked out. And before I stop this session for today, I just want to convey there are paid courses are also there in Unacademy Learning App. If you want to join the paid course in the Unacademy Learning App, you need to use this code VT10. When you are able to use this code VT10, directly 10% discount will come on all the courses in Unacademy Learning App. One thing, and I can recommend this 12 months subscription. I can recommend this 12-month subscription to the students who are in final year. Final year. Whereas I can recommend this 24 months subscription course to the students who are in third year, or I can say second year. So this is my recommendation, and after 10% discount you are going to get this 12 months subscription course for 22,225, whereas this 24-month subscription course for 39,600. This is in case of plus course. Now every day my class is I just want to confirm one more thing. Every day my class is happening by 11 a.m. So if you are a serious aspirant of GATE or ESE or any other competitive examination, definitely I'm pretty much sure like uh, you can come down to this platform and you can learn the concept. There is no doubt at all. So every day my class is happening by 11 a.m. and I can also recommend Kamalakar sir's Pandey's class also. Every day his class is happening by 9 a.m, right? So please take use of Kamalakar sir Pandey's classes also. I can recommend him. And one more thing, before the end of the session, you are getting all this for free of cost, na? So you please share this to your friends so that they will also get benefited, right? And please subscribe to our channel. Let's Crack Gate and ESC Civil YouTube channel. Don't forget to press the bell icon. If you press the bell icon, the future coming videos will also be notified to you. So that is one thing just I want to convey again and again. Don't forget to press the bell icon. Right. Please subscribe to our video lectures and please raise a thumbs up so that we will also get benefited and your friends will also get benefited. And for your guys, for to clarify your doubts, I had already started a Telegram group for you. And the name of the Telegram channel is Let's Crack Gate and ESC. And another Telegram channel is Unacademy underscore Civil Engineer Tilak. If you come down to this channel, definitely we are able to take care of your doubts. If you want to come down to this channel, use this link which is given below, Unacademy underscore Civil underscore Engineer underscore Tilak. Use this link which is given below. You guys will be redirected to my Telegram channel. When you come down to our Telegram channel, you are able to post your doubts. We will take care of your doubts definitely, right? So this is the end of the session. Thank you very much. Thank you.